If you have not seen the part 1 of this video, I suggest you to go through the part 1 of dB video before watching this video. So some more interesting things about dB or decibels. So how do you get dB for a single number? So you are given just a single number, while for dB calculation you need a ratio. So for example, what is the dB of 10 watts? Remember, dB is a ratio, so this number also needs a denominator. So in this case, take the denominator as 1 watts. So now the decibel calculation is logarithmic value of 10 over 1 and the value is 10 dB. These are the two important relationships which we need to remember. One is a factor of 2 or half, other one is factor of 10 or 1/10. So if you take ratio of two numbers and if the result is half, then the value is minus 3 dB. Now if you take two numbers and the ratio is double, then the value is 3 dB. Similarly, if you take ratio and if the result is 1/10, then the value is minus 10 dB. Now if you take ratio of two numbers and one number is 10 times of the other number, then the value is 10 dB. A practical example is this image. If you remember, you would have studied about filters or amplifiers, and it is defined by a 3 dB bandwidth as shown here. So in absolute terms, what does that mean? It means this is a half power bandwidth. That means from the peak, when the power drops to half, or in decibels it drops to minus 3 dB or 3 dB below from the peak, is where you measure the system bandwidth between F1 and F2. So let us look at other frequently used relationships. Decibel with respect to 1 milliwatt is represented by dBm. So in case of dBm, the ratio is power on the numerator reference to 1 milliwatt in the denominator. Other relationship is dBc or decibels with respect to carrier power. In case of systems having up conversion or down conversion, we use carrier frequency. So in dBc scale, you can compare all other signal powers with respect to the carrier power. So you may want to compare power level of carrier with rest of the waveform. So it could be comparing carrier power with noise power or say other users power and so on. So we use dBc with respect to carrier. Then there are other relationships like dBW where you measure power with respect to 1 watt, and dBV where you measure voltage with respect to 1 volt, and dBi, so antenna engineers may remember, this is gain of an antenna with respect to an isotropic antenna. Finally, remember that decibel or dB is not a unit, but in common system analysis, even though it is unitless, it is considered as an unit and represented in system analysis. These are the commonly used dB relationships for a factor of 2 and factor of 10. It is important and it is also easy to remember both these tables. Please click on like and subscribe to our channel and click on the bell icon for regular updates.